Good evening, dear students. I am Nivedita Haldar, your chemistry teacher. I will discuss about the application of second law of thermodynamics. Okay, so for the application of second law of thermodynamics is a well-known and most important examples are Carnot engine. The Carnot engine. This is the PV plot, pressure versus volume plot, and this is the Carnot cycle A, B, C, D. The Carnot cycle that consisting of 4 steps AB, BC, CD and DA. The AB path is known as reversible isothermal expansion and the BC path is known as reversible adiabatic expansion and the CD path is reversible isothermal compression and the DA path is reversible adiabatic compression and the pressure, volume and temperature for A path is P1 V1 T1, for B it is P2 V2 T1, for C it is P3 V3 T2 and for D it is P4 V4 T2. So basically this AB path it absorbs the Q1 heat and it rejects the Q2 heat through the CD path. Okay, and the temperature for the AB path it is T1 and temperature for CD path it is a T2. So for step 1 it is a reversible isothermal expansion. Isothermal, that means temperature change for this process AB process, that is from A to B, the temperature change is 0. So dt is equal to 0 and heat absorbed, that is Q1. Now delta U, that is change in internal energy, is equal to CVdt, as if dt is equal to 0 for here. So delta U, that is equal to 0. So change in internal energy for isothermal reversible isothermal expansion is also 0. So from first law of thermodynamics we can easily write that this Q1 is equal to W1 equal to nRT1 ln V2 by V1. Okay. Now for step 2, this is a path, that is B2C. It is a reversible adiabatic expansion. Adiabatic, that means heat absorbed or heat rejected, that will be 0. That is change in heat, that will be 0 for this process B2C. So W2 is equal to minus delta U, that is minus NCV T2 minus T1, that is N for N molar ideal gas, we can say for 1 molar N equal to 1. Okay. Step 3 is a C to D path. It is a reversible isothermal compression and the temperature for this whole path is T2 and heat rejected, that is Q2. As it is a reversible isothermal, that means dt is equal to 0. So same for the AB process, that is delta U, that is change in internal energy, that will be equal to 0, as the internal energy change delta U is equal to CV dt. So you can easily say that internal energy change is equal to 0. So from first law of thermodynamics we can say that Q2 is equal to W3, that is equal to nRT2 ln V4 by V3. Okay. And the last one, that is the step 4, that is D2A path, that is a reversible adiabatic compression, and the dq is equal to 0 as this process is adiabatic. And from the first law of thermodynamics you can write that W4, that is the work done for this fourth process, that is equal to minus delta U, that is internal energy change, that is equal to minus n Cv T1 minus T2. Okay, so for 1 mole you can write that is Cv into T1 minus T2. The total work done, that is W1 plus W2 plus W3 plus W4, that is the total work done for the Carnot engine, is the summation of the work done of these 4 individual processes. Okay, so that total work done, that will be equal to nRT1 ln V2 by V1 plus nRT2 ln V4 by V3, because the work done for the W2 and W4, that is for adiabatic process, that will be cancelled out to each other. Okay, so heat absorbed, that is Q1 for the AB process A to B, that is will be equal to nRT1 ln V2 by V1. Now for adiabatic process only, we can say that T into V to the power gamma minus 1 equal to constant, where gamma is equal to Cp by Cv. So from that relation, from the Carnot cycle, we can easily write for these two adiabatic process, that is B2C and D2A, that is T1 into V to the power gamma minus 1 is equal to T2 into V3 to the power gamma minus 1, and T1 V1 to the power gamma minus 1 is equal to T2 into V4 to the power gamma minus 1. So from this two relation, we can easily reach this conclusion, that is V4 by V3 is equal to V1 by V2. Now the efficiency of Carnot engine, that is equal to work done by the process, work done by this heat engine by heat absorbed by this Carnot engine. Okay, so that is nRT1 ln V2 by V1 plus nRT2 ln V4 by V3, that is the work done as we discussed above. Okay, and heat absorbed, that is nRT1 ln V2 by V1. So we can easily replace this V4 by V3 using this relation, that is V4 by V3 is equal to V1 by V2. So from that we can easily write nRT1 ln V2 by V1 minus nRT2 ln V2 by V1 by nRT1 ln V2 by V1. So from that we can say that efficiency is equal to T1 minus T2 by T1, or 1 minus T2 by T1, where T1 is temperature of hot reservoir and T2 is temperature of cold reservoir. So this is the discussion about the work done for this Carnot engine and efficiency of Carnot engine. And it is most important that the efficiency of Carnot engine is always less than 1. Okay, so 100% efficiency is not possible for Carnot engine. Okay, thank you.